Hello and welcome to the second video in the LogicWorks introduction series. Today we will be going over selecting, deleting, copying, and moving objects. We will also look at pin numbering and connection by name. All of this material is covered in the tutorial that accompanies the program. So if you want to review it on your own, just go to the Help menu and select the tutorial. Okay, so let's get started by opening up the file we created in tutorial number 1. And there we go. We're up and simulating. So let's stop the simulator and do a little editing. Now, one of the other tools that comes in handy is basically the deletion tool. It's a lightning bolt for zapping things. And the advantage of the zap is that it can be used to remove aligned segments. So, for example, we can remove that segment right there. And of course there's undo, so we do the Command Z to undo it. We could, of course, delete the entire segment by just selecting it and hitting the delete key. And we'll bring it back. But in this particular case, we just want to delete this segment right here. So one click and it's gone. And the reason is we want to add some more circuitry in there. So let's terminate the zap tool by hitting the space bar. Go over back to our demo lib. And what we're going to do here is grab ourselves octal buffer. Or pardon me, an open collector buffer. So here it is. Now we need to rotate that, and we can do that with the arrow keys. So we press the left arrow key and we get a rotated device. Now we'll just lay it down here, connect it on, terminate the placement mode, and basically draw the signal out from the end of the pin and probably move it over a bit. So if we do that. Now we're going to need a resistor as well. Pull up resistor, so we'll go and grab ourselves a resistor. Double click on it, move over here, and again we can play around with the arrow keys to rotate it in the orientation we want. So we'll place that right there. Terminate by hitting the space bar, and now go back up and grab ourselves +5. And again we'll rotate this so we get what we want, and we place that there. Okay, we've added that little extra bit of circuitry. Now we've dragged single devices before, but I'll demonstrate that you can also drag a group of devices. So let's select this one, hold the shift key down, select that one, and we can move the whole lot over a little bit, or move it back. So that's moving a group of objects. Now I want to do a bit more naming, so let's go over and grab the name tool, and I'll click on this line segment here and type in D7, and I'll click this one and type D6. So we've got those two signals named. And the other thing I'd like to do is add ourselves another device. We'll grab this inverter and we'll place it down here. Now what I'm about to demonstrate is connect by name. So first of all we'll set this up and draw a signal out each side and get our naming tool. And come over here, click on this, type in D7, and over here we'll click in not D7. And terminate the naming mode and turn the simulator back on. And if you take a look at the timing window, you'll see that D7 and not D7 are being displayed. And so what's being demonstrated is that this line segment here is connected to this line segment logically by the fact that they're named D7. And it comes in handy, keeps circuits from getting cluttered. It's just another way of connecting things. Okay, let's select this entire circuit by drawing a selection rectangle. There we go. And we can do that, and then we can go up and copy. We could create another design and paste it if we wish in there. And there's another copy of it. Simple. I'll just get rid of that one because we're not going to use it. So I'll say don't save. You could, of course, have pasted it down back into the same circuit. And that comes in handy when you're replicating a bunch of hardware like a RAM array or something along those lines. Okay, now the naming tool we've used so far to name signals. You can also use the naming tool to name a device. So in this case here, I'm going to click on the device, hold the mouse down, and let go just up above. And it says dev1, but I want to call it u1, so I'll type in u1. Okay, let's terminate the name tool. Now we can just grab the name there. When we select it, it will also select the corresponding device. We can move the name by just clicking and dragging it so it's centered over the device. Now another interesting feature is the ability to associate attributes with any device or signal or pin. So if we select this device by clicking on it, we right click on it and we do attributes, we can set attributes for different uses. So in this particular case, U1, the name is U1. It sets that name attribute. We could also set up a spice model here, or we could, if it was a resistor, set some value in here. So let's go back and actually select a clock maybe. So if we do that and do right click on it, do attributes, we could set the value to be 14.288 megahertz. So that's if you want to associate information with a device. And you can create your own attributes, or you can use the ones that come with the program. Okay, let's have a look at pin numbering. Let's go get the naming tool again. In this case, we're going to click really close in where the pin is. And we can type a number like 7, or let's say 5. And that's our pin number. And we can verify that by selecting the device and doing a device info and select pin info. And we can go through the pins on that device. Now the first pin, pin 1, hasn't got a number on it, so we could add the number here as well. So we could say 1. And then we could say next pin, and then we'll see our 5 that we did using the naming tool. So there's two ways to add to add pin numbers. And you will see that there's pin 1 and there's pin 5. The other thing you can do with the name tool is actually just use it to put down random text. If you just click somewhere out in open space, you can then type in a message. Something like the following circuit performs, and then describe exactly what it does. Anyway, basically you can terminate that by hitting the escape key, or the space, well, not the space bar in this case, the escape key, and you've got a piece of random text, and you can drag the random text around. Okay, now we're going to cover busing, and in order to do that, I'm going to modify the circuit a little bit. I'm going to take my zap tool and get rid of this vertical line here, and these two lines here, and those names. I'll also get rid of this line here, and I'll grab these guys and move them over a little bit, and I'll grab this guy and move him up a little bit. So busing is just a method for collecting a group of signals and portraying them as one single line, be it a thick line to indicate that it's a bus. So here we go. We go up to drawing and do new breakout. and in this case we're going to type in D0.7, which basically means we're creating a bus with 8 items in it. The items inside will be D0 through D7. So we say OK, and we get ourselves a little breakout. Now the breakout happens to be pointing in the wrong way, so we use the arrow key to switch it around, and we butt it up right against there. Okay, and we terminate the placement mode by hitting the space bar. Now we'll create a couple other breakouts. The top one we'll create is D6.7, and we'll spin it around and we'll connect it there. And then we'll do a D0, a single breakout, and we'll connect it there. And we'll do another single breakout, D7, or pardon me, yes, D7, and we'll put it here. Now, unlike signals, buses do not have connect by name, so these have to be physically connected. So if we drag off the bottom of that bus, we'll get a nice thick line, and we can connect these buses all up. And there we go. We've got a bus connecting 4 or 5 components. Okay, before the circuit will work again, we have to connect this back up and maybe toggle the clear. And you will see that the signal propagate through the bus, and we're getting values out on the probe as we did before. And also, if we rename the feedback, this is called feedback, we should get some values on the feedback. And if we take a look at D7 and not D7, you'll see that they're inverse of each other. So everything's back to working, and that's busing. It comes in really handy. Okay, that's enough for today, so why don't we save this out. We'll save this one as tutorial number 2. Well, thank you for watching, and come back for tutorial number 3. We'll be going over some of the simulation features. And thank you.